Hello everyone, welcome to Elite Engineer, and this is a part 4 of our video of Introduction to Blockchain. So in this video we are going to see about mining. Now you'll be confused that I have put photo of civil engineering mining and we are studying about computer science. So this mining and that mining are different. Yes, you are right. But when I talk about mining, both are interrelated. In terms of definition, I am talking about mining. I'm talking about this word, the term mining. We are going to analyze the term and its definition in the coming video. So be there to see the complete part of term what we call as mining in blockchain. So whenever you talk about mining, whenever you talk about blockchain or cryptocurrencies, so there is always one term that comes to our mind, that is mining. So in this section, you learn about mining and what goes behind the scene also we are going to learn in this. So mining is a process of adding a block to the blockchain. In the previous video, what we have seen that how the blocks is being added, like whenever we do some transaction with the help of timestamps, there is one block addition that is happening. And after that, we have also seen the hashing. The hash is being generated of that block, and that hash will be stored to the next block. So after that, the previous block and the transaction and the timestamp will generate a separate hash for the next block. We have seen already in the previous slides. So where are we? We are here. The mining is a process of adding a block to the blockchain. Now, in a blockchain network such as a Bitcoin and Ethereum network, there are different types of computers. Now here in blockchain, basically we call different types of computers as nodes. So on a computer of a blockchain that adds a block to the blockchain are known as a miner nodes, or we call it as a mining nodes, or most simply when we talk about it, we call miners. So we will talk about the different types of nodes later on in this course. But for now, we'll talk about a particular type of node that is a miner node. And the role of the miner node is to add a block to the blockchain. But the problem is how the blocks are added. Now we are going to see how the blocks are added. So when we talk about broadcasting or transactions, when a transaction is being performed, the transaction is broadcasted to the network. Like this is the 1 transaction, 2 transaction, 3 transaction, 4 transaction, and what happened here is it is being broadcasted to the network. And here this is a mining nodes. Mining nodes typically try to include the transaction with the highest fee first. Now these are the transaction, right? 1, 2, 3, 4. Now this mining node will take 1 and 3 transaction. This mining node will take 2 and 3 transactions, and this mining node will take 1 and 4 transactions, right? Transactions are broadcasted to the mining nodes. These all transactions will broadcast it to them. Now it depends upon them to take and then which them assemble into the blocks to be mined. Now after that they will fight according to the different complexities, like which one they should mine. Whosoever will win, they will mine that block. We are going to see in the upcoming slides that same thing. Now each mining node may receive them at a different times, like what we have already seen in the previous, like mining node 1 is there, mining node 3 is there. Mining node 1 is receiving that 1, and then mining 3 is receiving 1, mining 2 is receiving 2, and mining 3 is receiving 4. In such a fashion it is receiving, right? So they will receive at different times. As a node receives transactions, it will try to include them into the blocks. We have already seen the previous slides, like when transaction will come, it will compile and it will form, it will try to come in a block. And that block will be added to the blockchain. So observe that each node is free to include whatever transaction they want in the block. In practice, which transactions get included in a block depends upon number of factors, such as transaction fees, transaction size, and order of arrival, and so on. There are lots and lots of factors. At this point, transactions are included in a block, but which are not yet added to the blockchain are known as unconfirmed transactions. Once a block is filled with the transactions, a node will attempt to add the block to the blockchain. Now here comes the problem. What is the problem now? There is a problem with so many miners out there. Who gets to add the block to the blockchain? Like we have already seen, this transaction is being broadcasted to the network. Now who will mine the block? That is a problem. Now we need to solve this problem. So let's solve the problem. Then comes the mining process to solve that problem. Now, in order to slow down the rate of adding the blocks to the blockchain, the block consensus protocol dictates a network difficulty level. There is some difficulty target come in the block addition process. In order to be successfully add a block to the blockchain, a miner would hash the content of a block and check that hash meets the criteria set by difficulty target. For example, the resultant hash must start with the 5 zeros and so on. As more miners try to join the network, difficulty level increases. For example, the hash must now start with the 6 zeros and so on. This allows the blocks to be added to the blockchain at a consistent rate. Now what happened here is, we already have some transactions and we have a timestamp. Now there will be hash of the previous block that we already stored. Now what happened here is, as the miners will increase, the network difficulty level, the difficulty target will also increase, so that they will fight among themselves to solve one mathematical problem, you can say. Okay, whosoever will solve the problem, he will win. Means he will have opportunity to get the mining fees and mine the block to the blockchain. Now the hash of the current block would be there, and the hash must meet the network difficulty target. Okay, so this is the main aim of mining process. But wait a minute, the content of a block is fixed, so no matter how you hash it, the resultant hash is always the same. Okay, so content is always same. Every time the content is same, so hash will be same. I have already told you in the previous slides. So how you ensure that the resultant hash can meet the difficulty target? Now that is also the problem, because when the content is same, hash is same, now how you will meet the difficulty target which you want to be increased when the miners will increase? To do that, miners add a nonce to the block, which stands for number used once. Nonce, number used once. Okay, now what happened here is, we have a network difficulty, we have a transactions, we have a timestamp, we have a hash of previous block, then we have a network difficulty level, and one more thing comes up in this, that is our nonce. Okay, so nonce, what does it do? The miner add a nonce to the block which ensures a number used once. Now next will be the hash of the current block and the hash that must meet the network difficulty target, right? Now the first miner who meets the targets gets to claim the reward and adds to the blocks to the blockchain. I've already told. Now we have a different difficulty level, right? So miner will fight amongst themselves. Whosoever will win, he will add the block to the blockchain. Now it will broadcast the block to the other nodes so that they can verify the claim and stop working on the current work of mining their own block. Like everyone is fighting. One block won. Now what happened here is, he broadcasts that added block to all the other nodes so that they can verify and stop working on the current work which they are doing, because it will waste the power, because it requires a high amount of power to process the block to the blockchain. Right, the miners would drop their current work and process mining to the new block and start all over again with the different transactions. The transactions that were not included in the block that was successfully mined will be added to the next block to be mined. Right, this is very easy, very simple, right? Now miners. In case of Bitcoin, the block reward initially was 50 BTC and will have every 210,000 blocks. At the time of writing, the block reward is currently at 12.5 BTC and it will eventually be reduced to 0 after 64 halving events. For Ethereum, the reward for mining a block is currently 2 Ethereum. Okay, that is 2 Ethers. That is a currency for Ethereum. And the block adding rate for Bitcoin, the network adjusts the difficulty of puzzle so that every new block is being mined roughly every 10 minutes. For Ethereum, a block is mined approximately every 14 seconds. So you know, the Ethereum is better. So that's why we are using Ethereum also. And we are going to learn Ethereum ID. We are going to develop our projects in Ethereum IDE also. So you will feel a difference and you will explore a variety of things in our Ethereum IDE. Now, thank you for watching this video. I hope you enjoyed this video. See you in the next video. Bye bye.